Okay, in this video, we're just going to have a look at the next section. So we're still on chapter 5.2. Now, I thought it might be a little bit easier to have a look at a screen capture rather than writing it all out. So we've got a quartic polynomial has up to four linear factors. Okay, this is what I was saying before, where we can have different combinations of linear factors. Okay, so where they cross the x-axis. So one solution is for a quartic to have four distinct linear factors. So that's where it touches the x-axis four times at four distinct individual points. Now another option we have is one repeated factor, which means it touches the x-axis once, and there's other two factors there. So that would be a turning point on the x-axis. It's like what we were looking at for cubics, where it touches the x-axis once and then we have one other linear factor. Another option is if we have two repeated linear factors. So now we have two turning points on the same set of axes, and the other option is if we have one factor. And we have one more, is a factor of multiplicity 4y. So this case in which the graph has a minimum turning point at a, 0. Not too worried about those 2 points there. These 3 points here are going to be the most important. So we'll just be looking at some sign diagrams, and we'll do some examples. So here's an example for when we have 4 points. Okay, going to touch the x-axis 4 times, and obviously it goes up and down. Here's an example for 3 points. So we can see there's a turning point here, and it crosses the axis twice over here. So this is what the graph would look like in its curved form. The third example, where we have two turning points on the same set of axes, okay, just looks like something like this. And our last point is when we have two distinct points, one where we have a a point of inflection on the as our point on the x-axis, and then we have our other ordinary x point. So we'll do some examples in a moment. And there's a little summary there. So the single factor identifies an x-intercept where the graph cuts the x-axis. A repeated factor identifies an x-intercept which has a turning point, and the factor of multiplicity 3 identifies an x-intercept which has a stationary point of inflection. So that's that point there that we're looking at, and it's for those examples there where it has a point of inflection, which they haven't really stated in that summary, but that's just what we're looking at. So I'll leave this screen grab here for a moment and have a look at an